So just an overview of the talk. I'll tell you a little bit about the data warehouse. You're in for a bit of a treat. Many of you know that Amazon Retail Org is notoriously tight-lipped about what we do. This is the first time we're actually talking about what we do for data warehouse, largely to make sure you understand how we operate and the scale at which we operate. We'll then talk about the Redshift integration project, what we tried to do this year, what we accomplished. And then we'll tell you some of the best practices. Abhishek, my dev manager, will actually be going through a number of the best practices that we encountered working with Redshift. All right, let me begin. So the Amazon Data Warehouse, this is the authoritative repository of all data for Amazon. So when I say all of Amazon, I mean all of Amazon. So every order, every shipment, every item in the catalog. We are still actually running AWS's data warehouse. We're running all the digital stuff. So one-stop shopping for all your needs, okay? It's at that scale. This is petabytes of data, growing. The existing enterprise data warehouse is running an Oracle rack, and that's just plain rack, not Exadata for those familiar with that. We're also been using a little bit of MapReduce, and now we're going to be using Redshift, okay? My team owns and manages the hardware and the software. Aside from the Oracle database, it's all Amazon, all right? We design and build our own rack clusters. We have a team that does that. We're actually the only other team besides AWS that actually builds our own gear. And the big thing I mentioned, we're not part of AWS, right? We're part of the Amazon.com. So when you're giving a talk about AWS, I always like to introduce the elephant in the room. Normally, you've got an external customer who's independent, right? In this case, I'm not. So our mission is to provide our customers the best value, right? And what this means is we leverage AWS when and only if it provides the best value, right, for our customers. Quite frankly, if using AWS increases my cost, it increases the cost for all of Amazon's customers, all of our shoppers, which includes many of you, and we're not going to do that, right? The other thing I want to kind of call out, which earlier in Andy Jassy's keynote, some other keynotes about, oh, some people aren't moving all the way to AWS. That's us, all right? Why? Well, we have a huge infrastructure already, and moving it to the cloud the next, quite frankly, 3 to 5 years, it's not possible, right? Maybe eventually, but in the near term, it's not going there, all right? That's okay, right? Our job is to publish the best practices, so in general, not for this talk, but in general, if AWS is not the best, if we find other solutions, we're happy to share that. I mean, our job is to do the best job for the customer. Now, all this being said, it's conflict of interest. We get it. Take all of this with the appropriate grain of salt. All right. Here's a high-level view of how we're organized. All right. So we have a control plane, which is an ETL manager. So this is responsible for scheduling, for loading in the jobs, for figuring out which cluster to run them on. It then makes sure that the job finished, gets the results back from wherever we put them, and hands them to the customer. So data can go to S3, data can go to email, very popular output, publisher output. It can go directly to Windows shares, which a lot of our non-technical folks use for distributing data. So high level, very simple, is what we look like. All right, let me tell you about the growth story, right? Where this gets really, really interesting. Again, petabytes of data. All right, please look around this room. Take a good look. Imagine this room is full of refrigerators. That's what a petabyte looks like. All right, this is like a data center floor. That's the right size for one, and we're managing at that level. The growth of our data volume, our year-over-year storage growth is 67%. Processing volume is growing at 47% year-over-year, right? Which means as we scale up, we have bigger and bigger and bigger rooms, which is kind of a scary thought for us. Now, we'll talk about long-term sustainable scale. So we've been operating basically at this model where the blue line is demand. That's what 67% looks like. Okay? The green line is what you do if you've got big clusters, in particular big Oracle clusters, You buy them, and you have to buy them for some amount of runway, like a year-long runway. Okay? The reason you have to do that is even though you can design a rack system or even some other systems where you can expand them on the fly, if you don't reserve the space, it tends to go away. Somebody else takes it. In a company like ours, you can't just let a rack go idle. Somebody will put another rack there. So we basically have to pre-buy all of this stuff to make sure that we have that capacity. Well, you're wasting a lot of money early on. You have a ton of capacity you're not using. Right? What you want to get to, which we can with Redshift, is you basically just add on as you need to. That's what we're trying to get to. Here's another problem that we are hitting. We've hit pretty much every year. Green line there is your growth. Buy a bunch of capacity, you're good to go. I introduced in the previous line just a subtle change. Instead of 67%, 80%. Something happened. Somebody was wildly successful. Somebody started adding more data in, and your ramp goes up. All right? If you've bought capacity, it turns out the fastest you can get big Oracle rack systems in from the vendors, as we know this quite well, it's about 3 months. Right? That's as fast as you can go. It's as fast as you can react. Right? What we can do with things like Redshift or in the cloud is we can change quickly. Right? You can react much more readily to coping change. Right? So this is a problem that we're really looking to get ahead of to deal with our scale. The other thing I want to point out, which happened to us when we get into these situations, the change, you don't see it coming for a while. I mean, your demand growth bumps around, and so you might not see this until it's too late. Right? That's the key thing for large-scale enterprise data warehouses. All right, I want to talk about how we think about our world in terms of our cost per job. So our main efficiency metric, how we know we're doing well, we're a cost center, we want to be efficient, is cost per job. It's very simple, right? We use a very simple model, which is the CapEx, how much we're spending for servers and storage. We have our data center cost, and we have a vendor support, okay? Divide that by peak jobs per day. That's basically what we're doing for our cost per job. That's how we model it. A lot of other people just focus on the cost per terabyte. That's OK until you start to having to replicate clusters, right? At which point, you really need to kind of model how many jobs you can do with that. So that's why we encourage this model. But even if you still do cost per terabyte, this is still pretty close. So what drives cost per job up? Biggest thing, number of disks. Right? As your data gets bigger, you're buying more disks. Second thing, number of servers. As your volume increases, you need more servers. Simple as that. Short-sighted negotiations. My friendly advice to all of you who are buying this gear, if you buy something from HP, EMC, et cetera, they come with 3-year prepaid support. And on that 4th year, if you still have it, well, support might be a little bit higher. Right? It's a little bit higher. So that's actually a key driver that we've seen that we're now dealing with. Data center costs. Turns out data center costs tend to go up, right? RAND power, all that good stuff. What drives it down? Also friendly advice if you're still in this world, bidding. If you have 2+ vendors, you can, in fact, get better prices. This is a great thing. Moore's Law. Disk gets cheaper. Vendors will fight this, right? Most vendors for SAN gear, you have to buy the disk from the vendor. So therefore, they artificially keep the prices up. All right. Data design, right? You can actually improve your efficiency by refactoring your tables. Right? It's no different than software. You can make your system better just by updating the data. It takes a while, you can do it. And finally, software, right? The actual database makes it much, much better. So, talk about current state and problems for our existing enterprise data warehouse. We are managing multiple multi-petabyte clusters. So we do this for redundancy and jobs. One thing I kind of called out, we don't actually have backups. The reason being is you cannot restore a petabyte from backup. It's like, OK, you're waiting for months. Even from S3, not going to happen. So we actually have multiple copies for redundancy in case a cluster dies. All right? So this gets you multiple jobs and redundancy. Every now and then somebody will ask you, why don't you use X? Why don't you use Teradata? Why don't you use Netezza, one of the other guys? All great products. We started with Oracle, and none of them were able to get to a cost per job that was lower, especially once you factored in a migration cost, right, which you have to do. Again, the data is stored in SANS, not Exadata. One of the things that we will have observed is this particular solution, it performs very poorly on large scans. So once you're scanning a table of 10 terabytes or more, this solution does not perform well, all right? And finally, again, long procurement cycle, 3-month minimum, and that's when you know what you're buying, right? As soon as you change vendors, have another bidding process, welcome to your 9-month cycle, right? Okay, let me tell you a little bit about the data warehouse integration project. We spent 2013, this past year, really evaluating Redshift for our data warehouse, all right? We knew it existed. Let's really see what it can do, all right? So really we wanted to understand, where does Redshift provide a better cost per job? One of the features of Redshift, which we find really attractive, is we don't have to go all in. We can figure out where's it better, where's it worse, and only use it where it's better, right? And we don't have to pay huge upfront costs, which is nice. And the big thing is, can we actually solve some pain with Redshift without introducing a lot of new pain? Okay? It's one thing to just lower your cost per job. That's great. Lovely. Good job, attaboy. We actually really want to provide net new business value. That's what we're really trying to do. Okay? So to do this, we picked 10,000 jobs and about 275 tables to copy over and see what we could get done. Okay? This is really just kind of an effort to see where it worked with a kind of a broad stroke, as opposed to focusing on any one particular thing. So the current state of affairs. Biggest cluster is a 20+1, and these are all 8XLs. We are using just shy of 60 total. We've got 4 clusters right now. Our peak daily jobs that we've been able to get to is 7,200, right? And this is 4,100 extracts, so that's basically a query pulling data out, and 3,000 loads, so that's putting data in, right? So here are some results. I'll let you guys look at this slide for a while, get your pictures up. Benchmarking. This is for the extracts, 4,100 extracts. Outperforming, 2,700 are outperforming. Excellent. 1,400 are underperforming. Not doing as well. All right. The average runtime, if you look at all of these, we're seeing Redshift about 4 and 3/4 minutes. And in Enterprise Data Warehouse, they're taken closer to 17 minutes. Okay? We've got a nice histogram up there for the scale, what's 10x faster, 5x, or things that are slower. The big thing that we observed, and we'll explain why later on, while extracts are faster, awesome, loads are a lot slower in general. Part of this is because of the extra overhead that we've had to do to make sure that the data has actually been properly loaded. Okay, I hand it over to Abhishek now. Thank you.
Thanks, Erik. Hi, everyone. I'm Abhishek. I'm the development manager in Amazon Data Warehouse team. I'm going to walk you through some of the best practices, or rather, I should say, the experience that we had while we are on our Redshift journey, the integration with Redshift. So here are some of the things that I'm going to talk about today that you or some of you in this room might worry about. If you're too small, then maybe not. But if you are at enterprise scale, you might have to worry about a few of these things that we thought we would like to share our experience on and get you guys through on what it takes to be an enterprise solution over Redshift. So some of the things that I'm going to talk about is how to get built, some of the issues around S3, what do you do about the primary key, what do you do about the idempotent loads, if you want to do that, or some of the administrative pain that you can get through, or you might have to worry about when you are an enterprise customer, and how do you really ensure that all the data that you really wanted to load inside Redshift is correct. Okay? So first things first, Amazon Redshift loads from S3. Now, I know some of you might have attended the note from Anurag, and they are changing the paradigm into some of the other avenues of loading into Redshift. But really now, when we had to work with them, it's only S3 that you get to load the data from. Now, what happens in Redshift is it really sees the data that you pointed to in a bucket or a prefix inside S3. Now, the problem is whatever you had loaded, if you're loading too frequently and then you want to consume it back into Redshift too frequently, it might so happen that you might end up missing some of the files. Now, if you are not that big, probably this might never happen to you. But if you do that quite often and as many times in the volume that we kind of deal with, this will eventually happen. So how do you do or mitigate that kind of stuff? Okay, so some of the best practices or some of our experiences that we had is you can really go about doing or using some of the internal stuff that Redshift offers to mitigate such kind of problem. So one of the things is you can do is system table validations. So there are some system tables. So this is more deep technical in terms of you go through the documentation. It's all available on the internet. That if you go through those system tables, there are some beautiful piece of information that you can make use of and ensure that whatever you wanted to load inside Redshift is actually getting loaded at that point of time. When you wanted to read the data or when you wanted to extract the data back from Redshift, the same thing you got to do from the unload side of the world. So there's the unload. So people who might know or have used Redshift, the copy is actually reading the data into Redshift, and unload is to get it out. So if you want to do that, you might want to also verify that whatever data that Redshift actually wrote in S3 is actually the intended data that you wanted to get out. So you can use STL unload log table to do that. One of the things that Redshift recently launched is the manifest support. So what's that? So what's exactly manifest? So manifest is nothing but the metadata of what exactly do you want to read or write onto from S3. So that kind of provides you an authoritative answer to what exactly needs to be read or what exactly needs to be written out when you're querying Redshift tables or when you're putting data into Redshift. Okay, so this is really powerful in terms of what exactly that you could do in terms of loading data. Earlier, it used to see only things in terms of whatever is there in the prefix, whatever is there in the S3 bucket. But now you can actually provide a list of files across S3 that it could get into Redshift. Another interesting thing which comes in Redshift, which does not come in Redshift, is Redshift do have the concept of primary key, but it does not enforce it. So what does it mean for you is you really need to worry about that if you want to ensure the data quality, you really need to worry that this kind of thing happens or the primary key gets enforced. So what we did is we introduced a temporary table on the fly, which used to check duplicates for the incoming data. We also had a fail fast mode, so we fail early in terms of catching the early offenders and see if the data did have repetition or duplicates in it. And then we put that in the target table and then kind of validate that data in terms of duplicates on the fly. Now you would see that this is a lot of overhead. Definitely it involves processing in between that that's not available on the fly, and as Eric has shared, that there are a few things that we are doing to ensure that some of the data correctness aspect happen, or some of the things that our users do not have to worry about, and we put it through. Another interesting thing that you might be interested in is idempotent loads. Which means that if you want to load the same data again and again, or you want to do the same process again and again, you should end up with the same output, right? So why do you need that? You need that to ensure that in any kind of load failure scenarios, in any kind of scenarios in which something went wrong, you just want to click a button, redo that again, okay? And then it should produce the same output or the same results. So you might have to worry about the idempotent loads when you're merging the data inside Redshift. So you want to leverage the primary key, the things related to that I talked about earlier. And then when you're actually loading the part of the data back into certain tables or only the fraction of the data that you wanted to get it corrected again. Okay. Talking about merges, so merge is not available out of the box, meaning there's no merge keyword in Redshift, or you can just not say that, okay, go merge this. You have to mimic the merge out into two-way fashion. Again, introduction of temporary tables works over here. You have to get the data staged out somewhere. You have to figure out what are the different inserts you need to do, what are the different updates that you need to do, and then you go about checking the duplicates of it, the primary key aspect of it, and all that happens in a transaction so that you can roll back if you're required, and you ensure that there is idempotency involved in this. Similarly, if you want to load part of the data back again, so if you have that kind of requirement, then Redshift does not provide a concept of partition, right? So like in Oracle world, you can just say, okay, yank this partition and then load it back again. Redshift does not have that concept. So how do you go about doing that? So what you can do is you can use the sort keys, which are available out of the box in Redshift, to align your data in such a way that the part of the data is really stacked together. So if you have that kind of data distribution and that kind of data sorted out in such a way, you can easily yank the data and then you can put that back in. Now, one of the interesting bits of this is if you do that so often, then you have to worry about that you might end up getting lots of blank spaces in between because Redshift really has soft deletes. And then you might have to worry about vacuuming your table or vacuuming your object so that it actually is really fast from the query performance perspective. Other things which were not available out of the box, but you can do if you have such a requirement, is that if you want to load part of the data into a Redshift table, so let's say you have got 10 columns, 1 to 10, but you only wanted to load 1 to 8 and not wanted to load the 9th and the 10th column, then you can, since we are an enterprise data warehouse, right, we cater to a lot of developer needs, a lot of analyst needs. So variety of things is actually driven by the analysts or the way that our users use that inside Amazon. So a few of the things were related to the column data load, or they wanted that on the fly, I should be able to filter out the data and then load into Redshift. So we, again, introduced temporary tables in between to do that on their behalf. And then they wanted to do that once when I'm loading data from S3 to Redshift, I should be able to do some sort of transformation in between and then get that particular column loaded. So if you wanted x plus y, or if you wanted x squared or something, before loading into the target table, you should be able to do that. Yeah. So coming to the more interesting bit, if when you are an enterprise customer, if you want to move enterprise level solution on Redshift, there are certain administration-based aspects that you need to worry about. So Redshift does not have a support for UDFs or user-defined functions. So what we did is we prepared a layer, a software layer on top of it, so that we could actually do a lot of user-defined function also in a scheduled manner. So for example, if you want to do some sort of retention management, some sort of statistic collection, or any kind of periodic function which ensures that your system stays healthy or your environment stays healthy over the period of time, then you might have to do that. So one of the key things that we kind of asked Redshift is to have UDF supports. So we did that with a software layer on top of that, which would execute the user-defined inputs and convert them into whatever things you wanted to do, and then do it over the JDBC connection. Okay, so Eric talked about some of the results on what we did and how the results looked like. So for cost per job, it's actually driving us 55% less for if you use Redshift in general. Now, if you ask me the math, I'll say Eric is going to answer that, but mostly he will not. So we have identified some of the things that we could do from our side, from our software side, and then Redshift is working very hard. The Redshift team is working very hard to get that even much better, and we believe that it could go even more to 66%. But the big wins are actually into the complex workload over the big tables. If you want to do that, the aggregations, the big complex aggregations, if you want them and you want to do them really fast, then Redshift is the way to go. Now, loads are relatively slower, and now we understand that because there is a bunch of overhead involved. If you want to ensure the correctness of the data, if you want to ensure that certain key things happen on the fly, then definitely there is going to be an overhead. But that's part of your ETL process, right? So that's all about how you process the data and how do you want to get that into Redshift. But in general, if you want to open it up for querying, it's pretty fast. So we have moved approximately 10,000 jobs onto a combination of 4 clusters, which are in total 60 nodes. And we could actually move almost half of our workload directly on Redshift. So that was pretty interesting because we were using Oracle, and we could probably move half of our workload onto Redshift, and that helps us out really well. Some of the things that we would want to do in 2014 is actually push the system a bit more. So we wanted to have some of our big tables, so big meaning really big in terms of a single table which might be more than 100 terabyte or 150 terabyte. We want to push that on Redshift and see how the Redshift performs, how that it scales, how are the queries on such big tables work out, how are the complex queries on this big system, or we need to solve certain issues in terms of how do you backfill or how do you get the data back quickly in time for such big tables, or how do you handle the retention challenges or the data expiry challenges when you have big tables. As of now, we have seen that in some of our workload, we are CPU bound in terms of how Redshift performance or how Redshift operates. But we are seeing that there are certain things that can be done, and we need to see how we can go away from the CPU bound limit. And some of the interactive analytics or third-party things that we would really want to hook in with Redshift and see how it performs in terms of the third-party apps or third-party software with Oracle and Redshift put together. So these are some of the things that we would be planning for 2014 and see how that goes. So maybe we'll talk next time about that. Okay. So I guess I'm done from my part. Thank you.
All right. Thank you.